Solubility is the amount that is able to dissolve. Usually measured in like grams per liter, grams per mil, or molarity, moles per liter. So basically a mass per unit of solvent is how solubility is measured. KSP is the concentration of the products. Now we would normally KEQ is concentration of products over reactants, but when you're doing a solubility question, remember, well, just like the one we just did, silver carbonate, it's solid going to aqueous, and we don't include solid in the KSP expression. So really, KSP is the concentration of the products multiplied together. So it's different than solubility, and solubility tells you exactly how much will dissolve. KSP just gives you an idea, is it a lot or is it a little? Is the KSP a large number? If KSP is large, more of it will dissolve. If KSP is low, less of it will dissolve. All right? It's all relative.
Like in solubility, large is like 10 to the negative.
For certain things, yeah. Okay. Let's look at net ionic briefly. What are the products of this reaction? It's a double replacement. So you're going to get silver chloride, sodium nitrate. Which one's a solid, if any? How do you know? You check the solubility chart. So we go to our data booklet. You will get a new data booklet for the final. You cannot use the one you've written all over.
Are there any things we should know that are not listed on the data booklet?
Acetate. Is that? But I'll tell you that. There it is right there. Chlorine and silver are insoluble. Low solubility. Sorry? If needed, yeah. So we know that that is a solid. So if we're going to write out the net ionic equation, everything else, because sodium and nitrates are always spectators, right? They don't really do anything. So we ignore them. So the net ionic would be, why am I writing sodium? Would just be silver ions plus chloride ions going to ADCl. Oh. All right, are we okay? How can you increase or decrease solubility? Most things it's temperature, not everything though.
Remember that first question about there was like something
If you increase the temperature, usually you get an increase in solubility. That is not always the case. For example, gases do not dissolve well in warm water, say. They dissolve better in colder water. Right? And there are some solids, I think one of the ones we looked at was cesium something, that is better, it's more soluble in a lower temperature. Okay? But you can also do common ion stuff. So we tie it to equilibrium. So if we have calcium carbonate, all right, so if we have calcium carbonate and I decide to add some, I don't know, no, we'll do silver nitrate. That'd make more sense. And I add silver nitrate to the solution. What is going to happen? First of all, does the nitrate do anything? No, it's always a spectator. So then you go to your data package. And there's nitrate there. Does nothing, soluble with everything. We look down. Carbonate here. It's soluble with these things, all the alkalis, protons, and ammonium, but everything else is low solubility. So that means that silver will react with this. And you'll get AgCO3 2 solid. Causes it to fall out of solution. So what does that do to the equilibrium of this? It pulls it this way, right? Because you pulled this out of solution now, and then this shifts to the right, and you get it dissolving more. So this causes a shift to the right. Okay. Conversely, what if I had it's not charged. What if I had ammonium carbonate in that solution? You're going to have a higher number of these, so it's going to push the equilibrium back that way, so the solubility of calcium carbonate would be less. Okay? Okay. All right. Let's do the math problems, because this is what the short answer will be. Does that make sense? That's basically just a KEQ problem. Okay? So all the most of the multiple choice on your test are going to be like sort of theory type problems. Which way is it going to go? Maybe do a tiny little math calculation. Blah. By the way, there's about 43-ish multiple choice questions. You've got like 3 hours. I'm going to finalize it over the weekend, but that probably won't change very much. I just got to change up the short answer. Why is it decreasing with ammonium carbonate? Because this carbonate, this is going to ionize, right? Because ammonium and carbonate, if you look at your data package, is dope. Hang on. I'm asking this question. Ammonium carbonate. Where's ammonium? There it is there. Ammonium carbonate is soluble, so it'll ionize. And then, so you've got CO3 ions, CO3 2 minus ions floating around, which are going to push the equilibrium back. Essentially, you're adding this, right? Which will spike it up and push it back. Does that make sense? Okay.
So like if it's pushing it towards this dissolving, it's less.
Yeah, because this would be a, sorry, I should have right, and on the test it will. This will have, that'll be a solid. Sorry. Okay. I will answer all exam questions on Monday.
No, like this is a question you can answer. Are there going to be multiple choice questions where we also have to explain why we should answer?
No, that would be in the short answer section. All right. Here we go. The math. Everybody likes the math. So we already did the one at the beginning of class. Do you want me to put that up? Okay. So you should, I'll just say, know how to find solubility from KSP. That's the question we did right at the beginning of class. Know how to find solubility from KSP. That's a pretty standard question. The other is how to find the KSP from solubility. That's what we'll do right now. So solubility of strontium fluoride is 1.0 times 10 to the minus 5 molar. What is the KSP? So we write out the reaction. Yes.
Is on the exam, is it going to be like every unit is going to be just like randomly going around?
No. No. I have to look at it, but I don't think so. No, they're kind of grouped together. Do you want me to scramble them? I won't scramble them. I won't scramble them. Okay, so we write the equation out. Make sure, what do you have to do with every equation before you can do anything with it? Balance it. Is this balanced? You better make sure it's balanced, because if it's not balanced, you're going to get everything wrong. Okay? All right. We're trying to find the KSP, so we need to write the KSP expression. What's the KSP expression? Concentration of strontium times the concentration of fluoride squared, right? Yes? Okay. So we know what the solubility is. It's 1.0 times 10 to the minus 5 molar. That means that when you put this into solution, we're going to pretend this for a sec. All you put concentration 1.0 times 10 to the minus 5, it all dissolves. It's not really like we're just saying that's how much dissolves. So the concentration of strontium would be 1.0 times 10 to the minus 5. But what's the concentration of fluorine? It's double that, right? Because there's 2 fluorines in every molecule here. So it's 2 times. Then you just plug it into the equation.
So I'm doing math right now.
I'm recording.
Oh, sorry, my bad. Are you actually?
Yeah.
Oh, sorry.
I'll be done in a bit. Okay. So the only trick with this is you got to remember to square that number. Okay? And then you just punch it in your calculator. I don't know what that is. Some number. Two times 10 to the negative 15. Anybody?
Yeah, it looks like 4.0 times 10 to the negative 15.
Boom. There's your KSP. That's a pretty straightforward question. Good? All right. The other type would be a common ion problem. This would be a good short answer. Let me repeat that. This would be a good short answer.
Are you even allowed to do that?
I already put a star next to it.
Yeah. Okay. So this is asking, what is solubility of, we'll use the same molecule, silver carbonate, in a 0.1 molar solution of sodium carbonate. So just to bring us back, right at the beginning of class, when we did the solubility of silver carbonate, we found it to be 1.3 times 10 to the minus 4 molar, right? That's what you did right at the beginning of class. Do you think the number will be bigger or smaller than that? It should be smaller, right? Because what's the first thing you do? You write out the reaction. So the looks like this, like that. And with nothing else, we got 1.3 times 10 to the minus 4. But now we're dumping it into solution of sodium carbonate. So this is an ice table question. How much carbonate do we have initially? Before you put in any of this, we just have a beaker sitting there of sodium carbonate. It's 2 silver and 1. That's important. Thank you. All right. We just have a beaker. We have a 0.1 molar concentration of sodium carbonate. Does everybody agree with that? What if it was the only trick here, not the only trick, but as if I had something like this. Now this molecule doesn't exist, but just pretend it did. Say that was a 3, like that. What would the initial concentration of carbonate be? 0.3. You have to multiply it by that number, okay? So just be aware of that. Because when this breaks up, you get 3 carbonate molecules for every 1. Okay? So just be aware of something like that. All right, but in this case, it's 0.1. So we have 0.1 molar. And we have no silver, and we have no this. Then we throw in X amount. We don't know how much amount. We just throw in X. How many silvers do we get? We get a 2X, and we get an X for a carbonate. So at equilibrium, we don't even care what's going on over on this side because it's solid, so we actually don't care. At equilibrium, we have 2X molecules of silver, and we have 0.1 plus X molar of carbonate. So if you don't remember to do the assumption thing, you're going to end up with a quadratic. You can solve it using the quadratic formula, be my guest, okay? But if you end up with a quadratic, there's a high probability you did something wrong, okay? We stay away from quadratics. We're allergic to quadratics in this class, okay? You can do it if you want, All right. But we can always make the assumption that x is smaller than 0.1. Yeah, you should write that. Oh no, that's so much work. No, just be like, nah. So we can assume this is just 0.1. And then you just write your KSP expression. It's the concentration of silver squared times the concentration of carbonate. Carbonate is 0.1, silver is 2x. And the KSP, which is pulled from your table, so then you're going to math it, and you're going to get x is equal to 4.6 times 10 to the minus 6 molar, which equals that. And that number is it compared to what we did right at the beginning of class, it's 1.3 times 10 to the minus 4, which is the bigger number? The first one, right? To the minus 4, to the minus 6. So it got less soluble, which makes perfect sense because we already had carbonate here, which pushes the equilibrium back that way. So we get less of it dissolving. Is that good? Any questions?
Do we still have to write the let x equal?
You don't have to, I'll let you not write that, but just be careful. Like say, I can't think of an example.
The concentration of the thing is like 2x. You want to make this.
Yes, like say this was, say this was x. Say this for, this is not the case clearly, but say this was 2x there. And you just solve for x. You'd have to double your answer, right? Or depending on what I was asking, divide it, blah, blah, blah. So just be careful about that.
I think it's smart.
To write what? Let x
So
equal?
like, let x equal.
You should, but if you can look at the table, you'd be okay.
Even just say like x equals something, so you know.
Yeah.
What you're looking at.
I know, because I see people forget at the end to do that little division thing or multiplication or whatever. All right, that's solubility. Monday we'll do acids and bases. That's solubility. Monday's acids and bases. Tuesday's redox, which we just did, and then we're done. I printed off an exam. I'll go get it for you in a sec.